Lesson 2. Chronic stress and resource depletion, how the body slips into depression. In the previous lesson, we looked at depression as a state of biological overload of the nervous system. We saw that it is not a sudden breakdown or a defect of the psyche, but the consequence of long-term processes taking place within the organism. In this lesson, we will focus on the mechanism that most often triggers and sustains this state, chronic stress and the gradual depletion of biological resources. Depression rarely appears overnight. Much more often, it is the result of an accumulation of small, repetitive burdens that, over a long period of time, do not cross the threshold of pain or drama, yet steadily limit the body's capacity for regeneration. As a result, the nervous system loses its ability to return to balance, and the state of overload begins to stabilize. The aim of this lesson is to show how stress operates over time, why the organism is unable to bounce back from exhaustion on its own, and at what point an adaptive stress response turns into a depressive state. 1. Stress as a process, not an event. In everyday understanding, stress is often associated with a single difficult event, a conflict, a loss, an exam, or a sudden life change. From a biological perspective, however, this is a simplification that makes it harder to understand the mechanism leading to depression. The organism does not respond with depression to one event, but to a process of prolonged load in which the stress system remains active for too long. Acute stress is a natural and adaptive response of the body. It mobilizes energy, increases alertness, and enables coping with a temporary threat. After the stimulus passes, however, the nervous system should return to a state of balance. The problem arises when stress has no clear beginning or end, and the organism functions in a state of constant readiness for weeks or months. In practice, chronic stress rarely takes the form of a single dominant factor. Much more often, it is the sum of many small burdens that seem manageable on their own, yet act continuously. Pressure of responsibility, lack of a sense of safety, constant availability, prolonged loneliness, or the necessity of caring for others, all of these elements sustain the activity of the stress axis, even if they are not experienced as dramatic. From a biological standpoint, the nervous system does not distinguish between serious and everyday stress. It responds to the duration of activation and the absence of regenerative phases. If the alarm system remains switched on long enough, the organism begins to function as if the threat were permanent, even under conditions of objective safety. This is precisely why depression so often develops silently. It is not accompanied by a single turning point event, but by a gradual shifting of the limits of biological resilience until the moment when the nervous system loses its capacity for self-regulation. Understanding stress as a process rather than an incident is crucial for further analysis of exhaustion and the mechanisms leading to a depressive state. 2. The mechanism of load accumulation. Chronic stress does not affect the organism in a linear way. Its key characteristic is accumulation, the gradual buildup of load that is not neutralized by regeneration. Each subsequent activation of the stress system adds to the previous one, even if it subjectively seems minor. The nervous system does not automatically reset. It requires real conditions of calming and recovery, which are often absent under conditions of chronic load. In the initial phase, the organism compensates for tension by drawing on energy and neurochemical reserves. Sleep becomes shorter, yet daytime functioning remains relatively stable. Over time, however, the safety buffer begins to shrink. Regeneration can no longer keep pace with the costs of mobilization, and each new day starts from a lower baseline than the previous one. It is precisely this mechanism that causes exhaustion to build gradually and often remain unnoticed for a long time. An important element of load accumulation is the fact that the organism adapts to overload, treating it as a new normal. Elevated cortisol levels, muscle tension, or an accelerated heart rate cease to be perceived as alarm signals. This apparent adaptation does not indicate improvement. On the contrary, it reflects the consolidation of unfavorable biological conditions in which the system functions with decreasing efficiency. Load accumulation also leads to a narrowing of the tolerance range. Stimuli that were previously neutral begin to trigger strong stress responses. Each additional task, conflict, or even the need to make a decision generates a disproportionately high biological cost. The nervous system then operates at the limits of its capacity, overreacting even to minor challenges. In this state, the organism increasingly relies on short-term strategies, suppressing emotions, withdrawing, slowing down activity, or, conversely, further mobilization at the expense of regeneration. None of these strategies solves the problem, because they do not remove the cause of accumulation, they merely allow temporary functioning despite growing overload. The mechanism of load accumulation is key to understanding why depression rarely has a clearly defined point of onset. It does not appear as a sudden turning point, but as the result of a long-term process in which the organism's capacity for compensation is gradually exhausted. 3. Depletion of biological resources. When the mechanism of load accumulation persists for a sufficient length of time, the organism enters a phase of biological resource depletion. This is not ordinary fatigue or a temporary drop in energy, but a state in which the nervous system loses its capacity for further compensation. The reserves it previously relied on become exhausted, and the pace of their restoration can no longer keep up with the ongoing costs of functioning. At the biological level, depletion means insufficient availability of metabolic energy for the brain and disrupted regulation of neurotransmitters. The nervous system shifts into a conservation mode, reducing the activity of structures responsible for initiative, planning, and drive. The organism is not refusing to cooperate, but protecting itself from further overload by narrowing its range of functioning to the minimum necessary for survival. A characteristic feature of this stage is the loss of the ability to regenerate, even under conditions of objective rest. Sleep no longer restores energy, breaks from work bring no relief, and short-lived positive stimuli do not lead to real improvement. This results from the fact that the mechanisms responsible for rebuilding resources, neuroplasticity, hormonal regulation, and circadian rhythm, remain blocked by the ongoing activation of the stress system. Biological resource depletion is also associated with a narrowing of the organism's response repertoire. The capacity for flexible adaptation to changing conditions fades, and the nervous system shifts into a reactive mode. Each new burden triggers an immediate stress response, because the system no longer has a safety buffer. In this state, even simple activities can generate a disproportionately high energy cost. An important aspect of depletion is the breakdown of regulatory feedback loops between different systems of the body. Communication between the nervous, hormonal, and immune systems becomes disrupted. Somatic symptoms emerge, such as chronic muscle tension, digestive complaints, pain of unclear origin, or reduced immunity. These are integral components of the depletion process, not additional health problems. At this stage, the organism is no longer functioning in an adaptive mode, but in a survival mode. Depression here is not an emotional reaction, but a biological consequence of a state in which the regulatory system has lost its ability to restore resources. 4. Why rest stops working. One of the most disorienting experiences in developing depression is the fact that rest no longer brings relief. Sleep, a free weekend, or even a longer break from responsibilities does not lead to real regeneration. From a biological perspective, this is not a paradox, but a predictable consequence of exhaustion of regulatory systems. In a state of chronic overload, the nervous system is unable to effectively switch from mobilization mode to regeneration mode. The stress axis remains active even when external demands temporarily disappear. Cortisol does not fall to levels that allow resource rebuilding, and the autonomic nervous system remains dominated by its sympathetic branch, responsible for alertness and tension. The organism appears to be resting, but biologically it is still operating in an alarm state. This is particularly evident in sleep disturbances. Even if a person sleeps for a sufficient number of hours, sleep is shallow and fragmented, and the phases of deep regeneration are shortened or disrupted. The brain does not complete a full cycle of synaptic renewal, and the hormonal system fails to properly synchronize with the circadian rhythm. As a result, the morning does not bring a sense of refreshment, but a continuation of the fatigue from the previous day. An exhausted nervous system also loses the ability to benefit from short-term sources of reinforcement. Pleasures that previously had a restorative effect no longer activate the reward system. Not because nothing brings joy, but because the biological mechanism responsible for experiencing pleasure is temporarily switched off. Rest based solely on passive withdrawal from duties is unable to break through this state. In this context, typical recommendations such as take a vacation, stop worrying, or just rest prove ineffective and sometimes even frustrating. They fail to account for the fact that the problem lies not in the amount of rest, but in the lack of a biological capacity for regeneration. The organism needs not only a break from stimuli, but above all a rebuilding of the regulatory mechanisms that enable a return to balance. Understanding why rest stops working is crucial for further analysis of depression. It shows that this condition does not resolve on its own with a temporary reduction in load. Without restoring the regulatory capacity of the nervous system, overload becomes entrenched and depression enters a self-perpetuating phase. 5. Different paths to the same state. Although the biological mechanism leading to depression is shared, the paths by which people arrive there can be very different. This is one of the reasons depression is often difficult to recognize. Its onset frequently does not resemble a classic breakdown, but unfolds over time and remains hidden within everyday functioning. From the perspective of the nervous system, however, the type of burden is less important. What matters are its duration, intensity, and the absence of regeneration. For some individuals, the source of overload is an excess of responsibility and prolonged performance pressure. Constant readiness, the necessity of making decisions, lack of real breaks, and the feeling that one cannot afford weakness keep the stress axis in a state of permanent activation. The organism operates for a long time at high speed until regulatory resources are eventually depleted. For others, the dominant factor is chronic loneliness or the absence of safe relationships. From a biological perspective, social isolation is a powerful stressor because the human nervous system is designed to function in relationship. The lack of stable contact, of being seen and needed, maintains a state of tension and uncertainty, even when life appears orderly on the outside. Another frequent, though less often discussed, path to depression is long-term caregiving of children, the ill, dependent individuals, or those who are socially excluded. Constant focus on others' needs, combined with postponing one's own regeneration, leads to gradual depletion of biological resources. Paradoxically, the most responsible and empathetic individuals are often particularly vulnerable in this group. In some cases, depression develops against a background of chronic existential stress, the sense of meaninglessness, prolonged uncertainty, living in conflict with one's values, or functioning under conditions that require constant self-suppression. Although this type of stress can be difficult to name clearly, its impact on the nervous system is just as real as that of material or occupational stressors. Regardless of the path taken, the final state is biologically very similar. An overloaded nervous system loses its capacity for self-regulation, regenerative resources are depleted, and the stress and reward mechanisms cease to function properly. This is why people with completely different life histories can experience very similar depressive symptoms. Understanding that different paths lead to the same state is important for the later stages of this book. It allows one to move away from comparing oneself to others and from the question "why me?" and instead focus on recognizing one's own mechanism of overload. 6. Burnout and depression, where the boundary lies. Burnout and depression are often used interchangeably, although they are not the same biological state. Both can begin in a similar way and both are linked to long-term stress, but they differ in the scope of overload and in the organism's capacity for self-regulation. Distinguishing between these two states is crucial because it determines the subsequent course of functional deterioration and the way the body responds to rest and changes in conditions. Burnout is a state of overload limited to a specific sphere of life, most often work, caregiving, or prolonged responsibility. Biologically, this means that the stress system is excessively activated in a particular context, but still retains the ability to quiet down outside of it. The stress axis reacts strongly in situations related to the burdensome role, while outside of it tension levels may decrease. The reward system functions selectively. What is associated with the burden ceases to bring satisfaction, but other areas of life may still evoke positive responses. Depression, by contrast, is a state of generalized overload affecting the entire organism. The nervous system loses its ability to regulate selectively, and the stress system remains active regardless of context. Sleep disturbances, loss of energy, and weakening of the reward system occur both at work and outside of it, in the morning, in the evening, on weekends, and during vacations. Rest no longer brings relief because the biological mechanisms responsible for regeneration are no longer available. An important distinguishing criterion is the organism's response to a reduction in load. In burnout, improved conditions, time off, or genuine relief lead to gradual regeneration and a partial return of energy. In depression, such measures do not bring clear improvement and sometimes even deepen the sense of helplessness, not because rest is wrong, but because the nervous system has lost the capacity to benefit from regeneration. It is also important to emphasize that burnout can develop into depression if overload persists too long and is not interrupted. In this sense, burnout can serve as a biological warning state, signaling that the system is approaching its tolerance limits. Depression, on the other hand, indicates that these limits have already been exceeded and that the organism is functioning in survival mode. From a clinical risk perspective, this distinction is fundamental. Depression is associated with a significantly higher risk of suicidal thoughts and behaviors, whereas burnout, though serious, leads to such outcomes far less often. Downplaying depression by labeling it as burnout delays recognition and makes it harder to take appropriate action. In summary, burnout concerns a person's relationship with a specific burden, whereas depression concerns the organism's overall capacity for living and regulation. Understanding this boundary is essential in order to accurately assess one's condition and not confuse warning signals with a full depressive state. 7. When stress becomes a depressive state. The transition from chronic stress to depression is rarely clear-cut. It is not a point that can be marked on a calendar, but a biological process in which the nervous system gradually loses its ability to return to balance. The key criterion is not the intensity of stress, but the loss of self-regulatory mechanisms. Stress remains an adaptive response as long as the organism is able to return to a resting state after a period of mobilization. Even if tension appears frequently, the system still retains flexibility, sleep restores, breaks bring relief, and reducing the load leads to a real improvement in functioning. The boundary is crossed when regeneration stops working regardless of external conditions. One of the first signals of a transition into a depressive state is the loss of daily variability. Under stress, functioning usually improves at least at certain times of the day or week. In depression, deterioration becomes relatively constant. Mornings, evenings, and days off no longer bring clear relief. The nervous system operates within a single, narrowed range of reactivity. Another important indicator is the disappearance of the reward system's response. Under stress, short-term positive stimuli, rest, contact with others, a change of environment still produce a response of improvement. In a depressive state, this response weakens or disappears because the biological mechanism of reinforcement ceases to function. The organism no longer receives a signal that effort has ended or been rewarded. The boundary between stress and depression also becomes apparent in cognitive functioning. Under stress, reductions in concentration and efficiency are variable and situation-dependent. In depression, these difficulties become persistent, context-independent, and disproportionate to current demands. The brain works more slowly, and even simple decision-making generates a high biological cost. Most importantly, the defining criterion of the transition into a depressive state is that the organism can no longer return to balance on its own. Even when the original stressor weakens or disappears, the regulatory system remains blocked. Depression is therefore not prolonged stress, but a state in which stress has triggered a process that the organism can no longer stop by itself. Understanding this moment has crucial practical significance. It allows one to distinguish a state in which genuine relief may be sufficient from a state that requires conscious regulatory intervention. Summary. In this lesson, we have shown that depression is most often not a sudden breakdown, but the final stage of long-term overload of the organism. Chronic stress acts cumulatively, gradually depleting biological resources and leading to a loss of the nervous system's capacity for self-regulation. At a certain point, sleep, rest, and load reduction stop working because regenerative mechanisms are blocked. A key distinction was made between burnout and depression. Burnout concerns a specific sphere of life and retains the capacity for improvement after genuine relief. Depression signifies generalized overload of the system, independent of context and associated with loss of reward system responsiveness and persistent functional decline. The boundary between stress and depression lies at the moment when the organism can no longer return to balance on its own, and symptoms persist despite changes in external conditions. This distinction is essential for accurately assessing one's condition. In the next lesson, we will move on to self-assessment based on biological and functional criteria, rather than subjective judgments.